My name is Jim Cahill. I am the Director of Facilities Planning here at UMass and Chair of the Green Building Design Committee. So welcome to all of you and thank you for coming to the first lecture in a six-part lecture series that's titled Solving Old Problems with New Ideas. And I think all six lectures are going to be fantastic. This is the first one and a good one to kick it off with. So the Green Building Design Committee, in cooperation, teamed up with facilities planning, with landscape architecture and regional planning, with architecture and design program here at UMass, the Historic Preservation Initiative with the College of Humanities and Fine Arts, and the environmental conservation to present this series. So a lot of work has gone into it, and the goal is to expand our collective knowledge and sensitivity towards sustainability on campus. And last year we sponsored a workshop series that was, I thought, fairly successful. It would have been nice if more people attended, but we put a lot more work into it this year. And I particularly want to thank our Green Building research team, Lawson Wilson, Katrina Spade, Catherine McCusker, and William Stanton, all in the audience here, and for the hard work that they did and the good work that they did to organize this lecture and to publicize it, and so we hope it's going to be a great success. And I would urge people to come to all six lectures because I think there's a lot of thought went into them. We've got a lot of faculty involvement on our Green Building Design Committee along with students. And so we wanted to make this a very rich experience for everybody, also make it very valuable in terms of promoting sustainability on the campus. So without further delay, I'm going to introduce Stephen Schreiber, who is the director of the architecture program here and member of the Green Building Design Committee, and he's going to introduce the first lecture. Stephen?
Thank you, Jim. So I've been asked to do a few what are called nuts and bolts. So the first one is to please silence your cell phone. Assuming that you are in only silence, we'll move on. Today's lecture is eligible for continuing education credits for both the AIA and the USGBC through the self-reporting system. On your seats is a short survey. Please take a minute to fill out question 1. These surveys are really important to us, so please grab those surveys, and I'm going to give you 60 seconds to fill out question 1. Let's turn my cell phone back on.
And there's some seats in the front if you want to come to the front. Going up here for your 60 seconds. Now let's go first dive.
All right, I think that was a UMass minute. If you'd like to find out about future events sponsored by the Green Building Committee, please leave your email address. After the lecture, complete the survey and return it to one of the students on your way out. This lecture is being recorded and will be made available through the facility planning website. So on to the main event. It's my pleasure to be the host and to be the introducer of Michael LeBlanc, who I've known for I think 6 or 7 years. He is a principal in a very innovative firm in Boston called Utile, and he's been in charge of numerous institutional, residential, and renovation projects, none of which I'll tell you about because he's going to tell you about that. He's one of our alums. In 1991, he graduated from the University of Massachusetts, where he got his BFA in architectural studies, and one of his professors, at least one of his professors is here, Arnold Friedman. In 1997, he graduated with distinction from Arizona State University, receiving the Henry Adams Medal, which is the school's highest academic honor. and co-winning the thesis prize. He then worked for a great firm in Arizona, Wendell Burnett. From 1998 to 2005, he worked at Machado Savetti, another very significant firm in Boston, rising to the position of associate in 2002. So some of the projects that he was involved with there include the Alston branch of the Boston Public Library, which is a beautiful building, the Getty Villa, the Provincetown Art Museum, which was the first LEED certified art museum in the United States. In addition to professional practice, he's taught design studios at Arizona State and at Northeastern University. He lives in Sharon, Massachusetts with his wife and 2 children, and you'll get to see his house. So, on PowerPoint. So please join me in welcoming back to UMass, Michael LeBlanc.
Stephen, thanks very much for that intro. I appreciate it. But I wanted to start with a question. Do I get learning units for this too?
I think you do. I think you might.
Okay. Do I get more or less? Or that's a joke. So anyway, I wanted to thank the Green Building Committee and Stephen for sponsoring me, and Lawson and Katrina for all the email and prep and all that, getting me up here. Not that it's that big a deal to get here from Boston, but no, I love coming back to Amherst. My 4.5, 5 years, I don't know, maybe it was at least that long. But my time here was some of the best time of my life, and so coming back here is always a real treat, and it's always an amazing treat to see Arnold, and whenever I come back, and I really do wish Bill Rupp were still here with us. Would love to see him as well. But so anyway, with that said. The topic of the lecture is one that when you give lectures like these to you go to an academic setting, oftentimes it's more just show your work, and there's no title, it's just here's what we do, here's how we do it, and and I really appreciate the rigor of really trying to have a topic here, right? And I think Lawson and Stephen and I went back and forth on a bunch of different ideas, and much of this is going to be, I think, at first a little overview of some of the stuff we do. So in that sense, kind of traditional in terms of a lecture, but then really getting into a sort of analysis of a certain segment of the work we do. As well as how that typical work can let itself into another way of thinking, and that segment of the work is adaptive reuse that we've done quite a lot of, and how we can take the lessons of buildings that we've adaptively reused back into new construction, and really the idea is how can we design buildings that we're designing for their next use, not necessarily the primary one, because these days buildings do tend to outlive their original programs, and there's a whole lot of great examples of that. And in the theme of being green, to me, what's more green than having a building which lasts 150 years and houses 5, 6, 7 different programs throughout its life, as opposed to one which is which lasts for 35, 40 years and then is a teardown. And I know I was just in the office of Dennis Swinford before this, and we were talking about a certain era of buildings which happened about 30, 40 years ago, where oil was cheap, insulation was not really a big consideration, and at the time new construction techniques and materials were coming on the market, specifically metal studs, and how that whole era of metal stud buildings with fiberglass, a small amount of fiberglass infill are really, a huge plague in the building industry right now, and there are so many of these buildings that are being re-looked at and rethought of, and having to tear off in full building envelopes and things like that. And I actually have one of those to show you as well. But so I'll get right into this. Just the quick overview of the firm. Utile, we have. I have 3 other partners, so there's 4 equal co-equity partners, and we all worked for Machado and Silvetti for a number of years. And to a certain extent, we're working on some of the most important projects there and being integral to the execution, the design, the administration, all aspects of those projects. And at a certain point, we kind of we're working all over the country. So in the case of buildings like these, we've got well, this is the building I did out in Arizona with Wendell Burnett, so that's not a Machado and Saletti building. But this is the Provincetown Art Museum. This is the Rockefeller Stone Barns down in Bocanegra Hills, New York. The Olson Library. This is the Arizona State University Hassayampa Dormitory Project, an academic village. Oh, again, one of the P-Town Art Museum. But also missing on this, the Getty Villa. And so we still referring to, me and my three partners, kind of traveling all over the country, very exciting, working on great projects. And then we all started to have kids. And then we all started to realize, well, this travel isn't all it's cracked up to be. So in a sense, we also were then thinking about starting a practice. And so when we finally did that, we decided very specifically that we were going to focus on the Boston area. And so I'll just quickly go back in here. This was just a slide I slipped in here as one of the interests of my own personally that as I was working at these other firms, and the idea of developing facades which had a certain specific contextual relationship to the places they were at, and trying to do so in a way that was in a modern expression of a sort of enduring vernacular, let's say. Anyway, so we decided to focus on Boston and really get to know Boston better than anybody, be the Boston expert, so to speak. And there's a lot of competition for that post. So in one sense, I don't know that we ever achieved that, but we did try to position ourselves in a way that, knowing that the Getty museums and all of the wonderful museums around the country had already been built, the economy was starting to not look so good, and where could we start to look for work, what markets could we look at, and really, like I said, becoming experts on a very kind of local area, specifically, Boston, and also really trying to become at least perceived as experts on the approvals process in the city of Boston, which is onerous at best, and the whole nature of how a project, how a developer buys land, then tries to figure out what they're going to build on it, and then tries to go through the approvals process, and then it gets kind of turned through the meat grinder of the neighborhoods, and all of this, and then by the time you get to the point where you've got an approved project, it's a different program, it's a different size, it's a different everything than you thought it was at the beginning, and really, how does one try to streamline that process or get to know it in a way that you can be tactical about trying to achieve an end, in terms of good design, highest and best used, and serving your clients well. The other thing that I think about Utile, which I think unique from, let's say, the origins of where all the partners came from, was that we decided very consciously that we were going to really work with our clients, in a very collaborative way, and we all have our own agenda, but at the same time, architecture is a bit of a service industry. So keeping that in mind, and always with the best possible design as a goal. Focusing our energy in certain places kind of allowed us to get to that goal. And so we found this diagram that Charles Eames had made. And it's interesting. What I like about it is it shows that if this is the area of interest of the architect, and this is the area of interest of your client, and then this bubble here represents the sort of public concerns in society as a whole, well then if we take this area here where all three overlap, and we focus 95% of our energy there, well then we're gonna come up with the best buildings or the best project possible. And so I think what differs sort of in that mindset from a lot of firms, at least a lot of firms as they were even just a few years ago, is that we saw this as a liberating moment, not a restricting one. This wasn't our big cave-in. We're just gonna coalesce to the whims of the client, but it was really about being able to find those territories where when we focus our energy, we were going to get the most result from it. So it was really that kind of a thought process. And it's one that, you know, we've, I think, fairly successfully been able to live by. So when we first started, you know, the housing market in Boston was booming, and it was really, it was really through the vehicle of a, you know, a robust housing market that we were able to start working on buildings of some size, you know, buildings that we could start getting built in these neighborhoods that would start, you know, going up with Utile signs on them during construction and getting our name out there and really getting some some good feedback from particular clients. You know, in the case of these urban infill projects, they were all always trying to solve a problem. And again, you know, Lawson, this is one of these, you know, old problem, new solution, and I actually think it's a new problem with an old solution. But these kind of post-industrial areas of South Boston, which were never they were never planned to be residential neighborhoods. They came along with you know, with blocks that had very wide dimensions. So in the case of this building, which we call the trolley house because it used to house trolleys for one of the little sightseeing tours in Boston. It's the front of the building is here on West 2nd Street, and the back of the building is here, and the name of the street's escaping me right now, but it went, you know, it was a through block condition. It was a 115-foot deep block. And so how do you end up trying to create good urbanism fronting, you know, keeping a tight, you know, facade on the street, holding the street line in a building that deep, which is too deep for a traditional double-loaded corridor. It's not deep enough to separate it into two buildings, and how do you do that? And coming up with a kind of a courtyard scheme here, and we worked on this collaboratively with the office of David Nielsen. This one, oops, and that one and this one right here, which are similar sites. They're right next to one another, so that you can see the trolley house there. This is the building right next to it. We call that 321. But this building had the same condition, and so really what it was trying to do was use a very functional equation of using point-loaded stairs instead of corridors, which, you know, this idea of the double-loaded corridor. Has anyone ever seen the movie The Shining? You know, the guy on the little big wheel running down that, you know, the corridor. That's what we wanted to avoid. We wanted to avoid that condition of the endless double-loaded corridor, which is oppressive and difficult, and so to create a building like this, which otherwise would have had a double-loaded corridor if the developer had their way, we were able to demonstrate by using these point stairs, you eliminated all of this corridor space in the building. Obviously the stairs have some cost of construction to them, but they took up about 50% the amount of square footage in the building as the corridors did, and at $425 a square foot in this neighborhood, the developer very quickly realized how much of an advantage this was going to be. Additionally, and just to show you that it's not only about the numbers, we were also trying to create a condition where instead of the long double-loaded corridor with doors off of it that, you know, in a dark hallway, you're going up a stair, and each of the stairs, in the case of this, at the four kind of major entries, and these two stairs here are kind of more back of house, egress related, that you're able to collect 3 or 4 units into each stair and have it be more like a South End row house, if everyone knows what the South End is in Boston. More of an old 19th century row house kind of community. So you've got 3, 4, 5 neighbors that you kind of see on a daily basis as opposed to, you know, 15, 20, 30. And it really changed the scale perceptually of the building, you know, in terms of how the communities work. It's another one of these urban infill housing projects. I'll try not to spend too much time dwelling on each one, but we do, you know, we're very self-reflective sometimes. And in the case of this, we made a diagram. We were having, I was having some consternation about our relationship with the developer in this case, who also happened to be the contractor. So they had their own separate entity who was the contractor, and they had brought in a real estate person, and there were all these entities kind of flying around, all of whom seemed to think they had the authority of the owner. And and we all know that it's really the architect that has all the authority. But so I, you know, we just made this diagram one day in the office because we're sitting here thinking to ourselves, we're getting all this feedback from all these different people, and how are we going to organize this? How are we going to prioritize it? And how do we give it a hierarchy? And so, you know, So we do stuff like this from time to time. So in addition to the urban infill housing work that we do, we also do a whole project type, I guess you'd call it, which we call the urban intervention or almost urban furniture types of projects. In this case, this is the Harbor Island Alliance Pavilion, which is basically a visitor center for the Harbor Park, the Harbor Islands National Park in Boston Harbor, which prior to this project, and I don't know if it's still the case, I don't think so, but was the nation's least well-attended national park. Now, this wouldn't be a big surprise if it wasn't 2 miles away from a 6 million person, metropolis. And so really what the National Park Service wanted to do was begin to publicize this. They wanted some kind of a structure which helped, which was a place where people could go to find out information, to orient themselves. What are the harbor islands? What can you do on them? If I want to do this, which island do I go to? What are the schedules of ferry boats? But also to be a kind of 3D calling card or a presence on the Greenway in Boston, which as many of you know is one of Boston's most important public spaces. It's not even close yet to being one of its best public spaces, but it's hopefully at some point it'll get there. So a very fun project, which what's interesting about the forms of the roofs here, which you can see these are the actual forms that were being cut with CNC routers and all that. We've had questions on these as to what the forms mean to us, and are they a seagull wings? Is it a sail of a ship? Is it? And the real answer is no. It's just a very fun way to get water off the top of the buildings. And so we were draining these things from one roof to the other down to a little water catch basin at the bottom, which then was helping to re-irrigate some of the gardens on the Greenway. So again, there's a kind of an empirical drive behind a lot of these things, which hopefully result in beautiful form. And it was really, I guess, a good example back to the Eames diagram of where our interest lied and the beautiful form of this, where the client's interest lied in collection of water and keeping people dry, in trying to overlap these complementary energies, let's say. This is another one of these projects that falls in the same category. And for those of you who know the Convention Center, pardon me, in Boston, the Raphael Vignoli building, just outside of that. So what you're looking at here, this is the overhanging cantilever of the building over Summer Street here, and just outside of that, the Convention Center wanted to have a marquee sign. So they hired us along with SGH, which is a structural engineering company, to come up with an idea for this. And we went through all kinds of studies on this, the Las Vegas casino signs and how these things work, don't work, what's good about them, what's obnoxious about them, and eventually came to a strategy that worked for the Convention Center. And the basic idea is that this lower part here is all high resolution LED screen. So it's information, it's up and coming exhibits, things like that. And then the top is low resolution, and that's more for let's say more experiential or atmospheric types of program. So it's not necessarily announcing anything, but maybe if there's a certain, if the flower show is happening there, that there's a kind of moving composition of flowers under or something, so that it became complementary to the information, but it also became a beacon, which you can see all the way up and down Summer Street, and is really, a particularly important moment where all of these conventioneers coming from South Station or from downtown, and someone points that way, and to be able to see the prow of the Convention Center roof hanging out over Summer Street, and this marquee sign all lit up, seemed like a sort of good urban organizer. And what you see here is this Andy Warhol-like composition here is just on Thursday of last week, we were testing the LEDs. They were turned on really for the first time, and we were cycling through the different colors and looking at this stuff, and so it was all very exciting stuff. So this is almost done. This is a kind of a stair ramp project that we worked on with a kind of loosely associated group of clients that came to us primarily or initially as a single potential hotel operator down there, and then they got the convention center somewhat involved. They got the a bunch of different property owners, and they were involved. And this was a way to get people from Summer Street, which is elevated about 30 feet above the Seaport District, get people down to the Seaport in an accessible way. Looking at the existing layout of the land there, I mean, there's very few ways to get from Summer Street down to the Seaport. There are two neighborhoods that really need to be connected because of either one on their own isn't a particularly robust full neighborhood, but together, you know, they form a much more meaningful neighborhood. And so so this connection really was important. And we were originally proposing that this connection be made by something like a hotel, which the lobby could span the distance, and that hotel lobby is that kind of interesting project type or public space, which is privately owned and operated and maintained, but open 24 hours a day, and anybody can walk right through it. So it's, you know, this kind of public-private, you know, collaborative type of space. A few other types of the project. This is a renovation project of a hotel in Provincetown, and this was an old Holiday Inn, which then became the Cape Inn, and now it's the Harbor Hotel Provincetown. And this is the largest hotel in Provincetown. It was 141 rooms when we got to it. It's 128 now. We suited some of the rooms and things like that. But what was interesting about this is this was, you know, a place where you'd go and you'd take a shower in the morning just because you felt like you just slept in the grossest place ever. And I hope nobody has been there and loves this place, because I know a lot of people, for whatever reason, loved it as it was. But we had a super enlightened client on this, and you know, we talked with this particular client group for a long time, whether they should buy it, not buy it. We, you know, made trips down there to talk about it before they even, you know, bought it, spent some time there. And finally, when they bought it, they hired us to renovate this for them, and it was a lot of fun. So what you've got, this is Commercial Street in Provincetown. So the water is right here. Actually, this dashed line is the high tide line, and so what you had originally was a hotel which was completely surrounded by parking lot, and that's mostly still true. But at the kind of couple of key spots, it's no longer true. So you've got two bars of rooms here, a pool area in the middle. All of this was renovated. The rooms are all renovated. We wanted to do much more extensive exterior renovations and repositioning of it, but budget didn't quite allow for it. But we did renovate the entire lobby, restaurant, lounge area as well. And one of the things we did was create this very cool gas fire pit, and then this outdoor deck area, which is covered and enclosed. This was an old porte cochere where the people would you know, come drop their car off. It would get valeted at one point. This is in the heyday of this particular hotel. It long since had been in disuse, and so so capturing that outdoor space is covered deck space, taking what was parking lot out in front here and making it, you know, sand dunes with grass, and then you know, adding this kind of live fire pit, which as people drive by in the evenings, they see the fire going, and all sorts of people sit out here. It's empty in this photo, but I can promise you it's almost never empty. It's quite amazing how people you know, kind of are attracted to the fire. We're not so different than bugs too, you know, those bug lights, right? It's something about fire. So the rooms went from being, you know, I guess, I don't know how you'd characterize them, but they were dark, they were nasty, and to being, you know, what the client sort of aspired to is a super clean, you know, modern look. They wanted to feel no frills, not bogged down, bright as possible. And so renovating all the rooms, and then also you know, the public spaces. So this is that, you know, old carport area with the captured sun deck and all that, looking out to the ocean. And part of that dunescape in front of the restaurant was so that the dunes come up just a little bit, so you don't have cars parked in front of you, but it also begins to screen the road, which is right there. And so, yes, you'll see cars go by here, but you don't feel like you're part of the road. The road surface actually disappears from view. Some of the interior spaces, curtains sure are great for hiding things that are otherwise immovable, like big fire standpipes, fire protection sprinkler standpipes, and things like that. I guess who doesn't love a bar? So a couple other types of projects we're looking at. We were doing some elementary school work, and in this case, this is a building. This is called the Mattahunt Elementary School. It's in Mattapan. It's in this really super cool location in the city. It is an urban school. It's an inner city school, but at the same time, it's on this piece of land which it's kind of surrounded by trees, and it's a real kind of unique condition there. And when we came to it, it looked like any hospital along I-80 and anywhere USA. It was just a totally white building with very small punched openings. And the one thing that was happening was that the building envelope was failing. The systems weren't working. There were breezes coming in. The kids were cold and drafty. But the ultimate embarrassment to the city was that one of the sprinkler pipes burst, and somebody driving by could actually see water pouring out of the third floor between the cracks in the building envelope. And normally you'd expect to see a pipe burst and result in a basement. Well, this was being seen on the outside of the building. So they decided they need to redo that. So lucky for us, we got a nice project out of it. And we took the tack that it's an elementary school. Kids respond to Legos. There was also an ethnic demographic there, which really was excited about the color of the building, and we tested several more, let's say, safer colors that the city had kind of preferred, and I think they preferred them not because they liked them better, but I think they thought that's what people would like in general. When we went to the school to show this to them, they almost unanimously loved this more robust color scheme. And so what was one of the most satisfying parts of this job was that we took what was, I thought, a brilliant building plan, which had small classroom pods on the second and third floors, all revolving around a central library space, which you had to move through to get from one side of the building to the other, and a fairly progressive floor plan, particularly for the 60s when this was done, and we're able to sort of hopefully make that a little more transparent on the outside of the building. And then there's also a very cool bridge moment in the building which connects us to a community center, which we got to redo as well. So that was also a fairly fun moment. And if anything, I suppose at a lecture like this I should be touting our greenness. That one, we insulated it really well. It had almost no insulation before, so that was green. But we do, we do, and I guess we're going to find out tomorrow night whether we won this or not. But this is this and that are some of the boards from a competition we recently entered. This is a competition with real sites and real building at the end of it. We had a developer partner with this. It's a competition put out by the BRA and the mayor. Mayor Menino in Boston. And the idea here was that you were supposed to be able to come up with multifamily housing projects which were prototypable, redeployable, and produced more energy than they consumed. So for various reasons, and the sites that they had for these weren't deep in the city sites. They were more in the fringes of the cities, more of the stick-built, wood-framed outskirts of the city. I'd say outlying, but I suppose that's not very flattering to some of those neighborhoods which I was born in, actually. And the idea is that coming up with a prototypable housing idea, which we've got to be able to build and make it work and sell it and have it work. But B, that other people could then use it as a blueprint for how to do this. And so once you get into some of the ring neighborhoods of the city, there's lots of these little empty sites that probably in the past had a triple decker on them, which I believe is Boston's most important contribution to architecture, by the way. But you know, the idea that you could create something which, you know, Joe Pickup, you know, builder can, you know, pull up with his pickup truck, his typical subs, his 4 guys, his carpenters that work with him, and build one of these things, and only with a little bit of extra help in terms of things like photovoltaics and all of that, be able to actually, you know, reproduce something like this. So anyway, this was our stab at it, and we'll soon know how we did. We also occasionally dabble in the single-family houses. So this is a very interesting client in the Adirondacks, and the this is a vacation house, and what's interesting is this particular house, contrasted with a couple of the next ones I'm going to show you, really are a little bit at the heart of some of what we're going to talk about here in a few minutes, and I'm going a little longer than I thought for this portion of it, but I apologize. That, you know, there is the idea in design of radical customization, which is, you know, that every building is very specific to a certain client in a certain place, and it can't be reproduced ever, anywhere, for any reason, and it's sacred. And that's fun to do. You know, we like that. If a client comes to us and gives us that as a program, sure. But those clients are increasingly harder and harder to find. And at the same time, you know, with building, you know, the cost of building on the rise, even through this whole, you know, last few years of recession, building and construction prices did not dip by that much, not even nearly as much as the real estate market did. And so we also like to look at things which are more, you know, the prototypical. And in the case of this, you know, we're now talking with a couple of different prefab companies about the idea of launching a series of, you know, cool, green, smallish, suburban houses. So you know, taking our show on the road out of the city and really starting to look at some of the suburban transit-oriented types of sites that might be out there. And this is specifically not an attempt to solve the let's say the affordable housing in the policy sense. We do a lot of affordable housing in our office, and it's you know, we probably put more affordable units on the market than we have market rate units. But in this case, you know, the goal is that, you know, we wanted to develop a house that, say, an architect could afford to live in, right? Which is increasingly harder and harder to do if you live in the Boston area. I know prices are a little more affordable out here, right, Stephen? But but you know, if you're within a, you know, a fairly broad ring of the city of Boston, and you also don't want to commute for 2 hours every day, you know, finding affordable, efficient, not too big, well-designed houses is not really an option. So that's really, you know, kind of, it's a subset of the other types of housing we do. And it's one of these things where, you know, and again, it's a conversation that Stephen and I have had before when I've come up on reviews, is you know, we always like to solve big problems with small solutions. And it's really the idea that, you know, planting the seeds of good ideas which are reproducible and redeployable. And we even had the opportunity to build one of these. And we did it in the form of my house. I was the guinea pig on this. And so in the case of this, you know, I was the architect, obviously. But I was also the general contractor, and I was also one of the carpenters, and I was also one of the concrete guys, and I was also, you know, so it was one of those cases where trying to build a house nights and weekends while trying to run a firm in the city. And at the end of the day, you know, we built this for about $110 a square foot, which in terms of construction in the Boston area is about 50% the cost of what you'd normally expect to see for a custom designed house. I guess the idea being that at some point these wouldn't be custom; they would be you know, part of a choice that someone would make. I want this one or that one or this one. So this particular house is all geothermal. You know, we've got lots of glass, floor-to-ceiling glass, very simple forms. You know, put a little extra money into the garage door so that it's a cool thing when you pull up, as opposed to, you know, something you don't want to see. And you know, without being too ambitious about it, you know, for not a lot of money, you know, putting together a house which is very livable. So I'll quickly go through some of this. We also do a lot of planning work. I think I said that earlier, but you know, this is a project in Dorchester. Just quickly, this is the UMass Red Line station on the T station on the Red Line. This is the Southeast Expressway in this direction to Boston, this direction to the South Shore. This particular client of ours had purchased 9 acres of land here. This is currently the site of, let's see, I think the Boston Globe building is right here. I think the WB 56 building's here, and then there's a Shaw's and a couple other kind of big box, not too dense things here. So we planned this neighborhood for them, you know, came up with block sizes, program types, you know, target tenants, things like that. And then also took this through, you know, an approvals process and got a certain zoning envelope approved for this client. And really there's a kind of artistry to these types of images where, you know, as architects we look at these and think, well, this isn't, you know, maybe such a beautiful rendering, but at a certain point, it's about creating a representation or an imagery which is readily interpretable, let's say, and playing off what we hope are the most optimistic and tendencies of people, that people will see in things what they would like to see. You know, you try to make images that are as friendly as possible, but that also leave as much open to interpretation so that people can place their own desires on a project. And this is a very useful tool when trying to get things approved. Similar image from that same project. And then lastly, and then I'll get into the other stuff, which is we've been doing some work overseas in Abu Dhabi, and so Abu Dhabi is kind of the, let's say well, Abu Dhabi and Dubai are, I guess, sister cities, you'd say. I suppose if you lived in either one of those, you'd be offended by that remark. But they're two cities which are separated by about 2 hours by car. Both in the UAE, the United Arab Emirates. Both cities have huge global ambitions. And the difference between the two is one is a purely financial center, the other is has all the petroleum wealth. And so Abu Dhabi is the one that seems to have all the petroleum wealth, and Dubai, when the markets crashed, Dubai was probably hit worse than any city in the world. And so many things stopped at that point there, but in Abu Dhabi things just kept going, and so they're now looking to, you know, to their credit with the Abu Dhabi 2030 plan, looking beyond oil. They realized, you know, in one of the sheikhs we had met with out there, somebody had in the royal family had said, you know, that my grandfather rode a camel, my dad rode a Rolls Royce, I drive a Rolls Royce. My son will drive a Rolls Royce, and my grandson will ride a camel. And so this may or may not be true, but the perspective is there that you know, the free ride will only go on so long, and while they have this resource, which is otherwise, you know, hurting so much of the other parts of the world, they're actually much more interested and serious about the greening of their residences, the greening of their cars, and all of that than we seem to be at the moment. and at the same time, looking to build up an infrastructure, both financial, entertainment, leisure, that once the oil does run dry, that they have an actual source of longevity and income. So basically, in this particular case, this is an island that wasn't there 2 years ago. All kind of put together by the dredging out of certain areas around the city for freight routes and things like that. But they decided to take this island, which is, just to give you scale, this is probably Lower Manhattan would be about, you know, this big here. So it's probably half the size of Lower Manhattan, and you know, it really is looking to be the financial center of Western Asia. What's interesting about Abu Dhabi is it's within a 5-hour flight of 3/4 of the world's population, which makes it incredibly convenient, even though the day I was there last time in July of last year, it was 123 degrees and 90% humidity. Which, having spent 5 years in Arizona, I thought I was totally equipped for the heat, and I realized I wasn't. So you know, they're looking beyond, trying to come up with an image for their city, one which is specifically not international style, but has a global appeal, one which is exclusively Arabic, which is contextual, which is environmental, which is not necessarily about a Muslim architecture, but really more about an Arabic and a Gulf vernacular. And that's why they had us doing these different studies for different buildings, which were, you know, none of this exists, and these are all ideas for how to get a city, which is basically, you know, add water, city appear, to have a kind of organic feel to it that isn't, you know, 90 or 100 of the same exact high-rise building, but buildings which all have their own flavor to them and have their own specific environmental response. So, future use. Sorry, it's taking me so long to get to this, but the idea here is that you know, at Northeastern where I teach, we a couple of years ago, and when I say we, two other people who I've talked a lot about this with, and then a few other colleagues that we teach with, Kyle Moe, who's been teaching at Northeastern for the last few years, who's now at the GSD, and Peter Wiederspan, who's been at Northeastern for many years. We teach what's called the comprehensive studio, which is the final studio that students take there. And we always wanted to gear this towards really, you know, taking a project beyond conceptual design, getting into the details, talking about systems integration, things like that. But at a certain point, you know, we started to have this thought that, you know, if we want to really add sustainability to this, we really need to talk about the longevity of buildings. And as we began to think about this, you know, we can make a building as efficient as possible, but if it gets torn down in 30, 40 years, then it was really a failure in some senses. So the idea that we started with, or the premise was that what if we had the students design buildings well that had no program, or that their program was next use, that, you know, that the program was an attempt to predict the future in a sense, or to make it so that you didn't have to predict the future. So we started looking at what buildings currently lend themselves to this idea. You know, and immediately the Fort Point Channel area of Boston with all of its 19th century brick warehouse buildings comes to mind, because these buildings have been, they all mostly started off as mills or shipping warehouses. They've turned into, you know, $700 square foot condominiums, apartments, furniture showrooms, law firms, all kinds of offices, paper supply stores, you name it, it's all there. And so how is it that we could begin to learn from the attributes of these types of buildings in terms of how we begin to look at the design of new buildings and being strategic about how we might do that? So, you know, looking at some of these buildings, and I won't dwell on this too much, but you know, the Achilles heel of the typical 19th century mill building, or the two, is that typically the column grid spacing in this case, you know, 11 feet, is not particularly useful and not flexible for much of anything. And so if there was a way to start thinking about that differently, I mean, there are ways to work housing into this, but at the same time, you know, 100 feet way too deep for double loaded. You know, to get a unit of housing here, and then one here and here, you know, you'd really have just, your apartments would be way too deep. And office space, well, yeah, that can work with that. And office seems to be the one program that has the least real requirements and demand on space. You know, beyond just certain size floor plates, which then become, you know, at least in the eyes of the real estate industry, leasable. But you know, looking at also the attributes of these buildings which made sense, which were, you know, in this case, the 13'6" floor-to-floor heights. You know, so I mean, one thing right off the bat that became clear is that, you know, floor-to-floor heights, building dimension sizes, and then structural grids became, you know, one of the real focuses here. And so looking at this idea from three different ways, you know, basically structure, enclosure, and then energy. In the case of structure, I mean, the first and most primary piece of this is for a building to be renovatable or reusable, it has to have a robust structure. Almost every different program you might tuck into a building by code is going to have a different live load calculation to it. So you want to be able to capture as many of those as possible. That's just from the basic, you know, loading standpoint, but then also the idea of structure that that allows for flexible space. So, like I said, the 11-foot grid spacing on these things doesn't work very well, but it's when you start to get longer spans that you begin to achieve this flexibility in a greater way. Enclosure, in the case again of the 4-point buildings, exclusively all brick. And we were thinking about, well, what is it about the brick that makes this a great enclosure system and one that's been so enduring? And other than brick being just a durable material, is that you can work on brick quite easily in terms of repointing it, or if there's a leak, it's pretty easily identifiable. Surface fixes to that system can be made, and small areas can be pulled out and redone. And when a failure happens, it doesn't tend to be a full system failure. It tends to be a very localized failure. So that was important too. And then energy systems, which in terms of the old 4-point buildings, well, they kind of ignore. And so that really became the area where we could start to say, not only still learn from the older buildings, but then begin to improve upon it. So if we built our 21st century 4-point warehouse building, or next use building, that seemed to be, among the areas that we could begin to then develop much more readily than the older buildings could. So, and from that systems integration became like one of the key elements. So it's not just adding air conditioning, but it's how do you do it, and there's all kinds of ways we'll talk about. And then there's really just, I put this slide up. This is the Renzo Piano project. It's the performance center, the Paganini Performance Center in Parma. And, I think it's beautiful because it used to be a multi-story building. It's now a single-story building with a triple height space. Walls and parts of the building that used to be interior are now exterior. There's a certain flexibility. I can promise you when it was built, it was not a performance arts center. And so there's a kind of flexibility to this building type, which seems to make a lot of sense. And again, it's a robust structure. In the case of this, you can start to see a much better clear span. And then an envelope which has thermal mass to it, which has longevity to it, and which can be an interior-exterior type of condition. So I'll quickly talk about a couple of renovation projects and adaptive reuse projects that we've done, and what we kind of learned from that. And this particular one I did while I was still at Machado and Savati, but this is the Rockefeller Stone Barns in Pecanico Hills, New York. And the idea here is that the Rockefellers were gonna donate this project back to the township of Pecanico Hills, and the people of Pecanico Hills said, "Please don't. We'll lose the taxes on it, and we'll have to maintain it, and we'll go bankrupt." So, as only a Rockefeller could do, they decided to turn this otherwise this series of Norman stone barns into a center for food and agriculture, and as nonprofit, self-sustaining, et cetera, et cetera. And so, program great. The story of the place is much better than the architecture that we did there, and it's really quite an amazing idea that allows for local growers to compete with Southwest growers throughout the course of the winter. There's a restaurant here which gets 75% of its produce and livestock from the site, as well as classrooms, administrative spaces, event spaces, and just it's also a kind of amateur petting zoo, I suppose, at the same time, where you can take your kids there and walk around and pet the pigs and the sheep and the chickens, and the next time you come, they'll all be different ones, but but it's still fun. You don't tell the kids that part though. So what we found is not too dissimilar from the Parma project, is that in the case of this building, there were these really incredibly good spans in an otherwise masonry building. In the case of this, there were almost 50-foot spans here in what was the old hay barn. This was a very cool section where trucks used to come in here. The hay would come up. There were these beautiful big stair towers inside, so that as the hay built up, you could go up the stair tower and walk out on the top of the hay and throw it down onto trucks after. But and then the old dairy barn here, which has about a 54-foot span clear in it, and it's still to this day. I can't figure out why someone would have, spent the time and effort and money, although I'm not so sure it cost that much, to get a 54-foot clear span in a barn which otherwise housed cows at the time. You know, cows have stalls, there's all kinds of opportunities to break that space up, to post up, but no, they didn't do that. I mean, it's a column-free space. Quite amazing. And in the case of this, this is the restaurant Blue Hill at the Stone Barns. There's also a kind of sister restaurant in the city. And the interior of this was done by Asper Guzzi Architects, Peter Guzzi, a very good friend of mine. And we were the kind of prime architects for the rest of the facility. So we were in charge of the landscape, the grounds, the buildings themselves, the infrastructure, all of the other event spaces, classrooms, and Asper Guzzi, who had worked with that particular restaurateur before, did the interiors of the restaurant, and they did, I think, a super nice job with it. But again, this idea of super robust structure, clear spans, really important. And in the case of systems integration, in some places you just have to make the decision, we're not going to be able to integrate it, because if we do, we're going to have to drop a ceiling so low it doesn't work. In the case of this, Peter's really excellent idea was to come up with an acoustic plaster ceiling, which vaulted. Now, this is a gabled ceiling. He came up with this parabola-like form, which allowed for a whole lot of infrastructure to run in and above that. So it's kind of a plenum, but at the same time, it exposes the trusses. It creates a very beautiful space. The old ceiling in here was plaster, and it ran along these kind of the bottom of this bowstring arch in this kind of vaulted way. It was actually quite beautiful at that point too. But and then just looking at what I loved about this is so much thought went into this building. When we got there, this is called the manure shed. We suddenly realized that it had one story of retail, and then it had a single story of double height space above it that was an old theater. We found the old theater. This is on the new third floor. You can see how chopped up the framing of this floor was. There are these large beams at the top here which span the entire 62 feet front to back on this, and this was the old balcony. So this floor hadn't previously been here. This is a roof drain that was added later. And so subsequently, we got into this building. We were incredibly nervous about renovating, and then all of a sudden we opened it up and realized that, we've got a completely column-free space on the third floor and second floor if we want it, and that the second floor structure was incredibly deep, wood timber framed, which were at one point holding up, a full auditorium. It was probably, I'd say, twice the size of this room, and interesting that these huge W's and beams, or I-beams here in that case, were there, and we were able to leave them exposed. And then one more renovation project here. This is the 38 Oxford project at Harvard. And so we were the ID group, who's a data center specialist, the architects of this building. So this was the old particle collider at the university, which had a very short active life. But what you're looking at here is, this is the Nucleus Labs, just recently completed by SOM. This here is the above grade manifestation of an old tunnel, which was a 1/4 mile circumference tunnel underground, in which particles were shot around and collided, like a miniature version of the Large Hadron Collider in Switzerland. And so we were asked to renovate this building to become A, a data center, and B, the labs, workshops, and high bay spaces for the LPPC program, which is the Large Particle Physics program at Harvard, which was also constructing devices and instruments which were then heading over to Switzerland to the Large Hadron. So this is where the tunnel now has 2 stories above grade. This was just one giant empty, which was about 35 feet high, and half of which was above grade. So the floor, when you stood at this, you were looking up 35 feet to the structure. But you were about 18 feet below grade at that point. So anyway, we came up with a scheme that we hoped, or we think, took advantage of that. But one of the interesting things was, again, another building which had clear span. Let me go to the next slide. Clear span from one side to the other. It had this interesting moment of walking in at grade where you were actually above the main floor, the main space below. So this being the view, as you'd come in at the entrance here, you'd then come to a balcony which would then overlook down into the high bay space. And then we organized the lab spaces, the different lab spaces, like game show Hollywood Squares, which is a spin-off of the super cool Hitchcock movie Rear Window, where Jimmy Stewart sits in his, with his broken leg in his chair, observing all of the matrix of apartments across the back alley from him. And the idea was that as people would enter the space, they'd look across this high bay space to all of these open labs, which we were going to use the same exact garage door that I used at my house, except for it was a kind of a hangar door configuration. So these glass doors, which could be set up so that people could view into those labs across from this high bay space, look down and see all of the different instruments and things getting built and constructed. And then these would also, because they were operable, allow for good verbal communication between the various researchers and the people working down in the shops in the high bay space, but also that if components needed to be brought by forklift or gantry around this high bay space and then up and loaded into each of these, there was an easy way to do that. This is a view of what it would have looked like, and this was among the projects that 2008 took as a casualty when the market fell. So a couple of buildings that I thought were worth pointing out. The Salk Institute, my favorite all-time building, and it's one which is not unlike the campus center here. I mean the Fine Arts Center in terms of its vintage and its language. But it's a building which, when it was being built, Lou Kahn had no idea that he was actually designing the world's best school of architecture as opposed to a research facility. And I say that jokingly. Nobody laughed. But when you look at it, I mean, this building has so many other uses it could possibly have. And so, I mean, just a brief look at the section of this. The idea that, Kahn isolated structure and he created these long spans. These long spans then gave the great alibi for an amazing plenum space for ultimate flexibility, which then allowed for all of these walls underneath those plenum spaces to be moved at any time you want. They're very disposable, movable, reconfigurable. And so I always thought of this as like, architecture studios. And I think it was mostly because when I was there, I wanted one of these to be my faculty office that I came up with this plan. But that there are the spaces which are purely functional, reproducible, flexible. There are the spaces which are contemplative, and then there are the places which are about solitary or privacy. So I guess contemplative being these types of spaces, the solitary being the moments up here in these offices, which are, by the way, these offices are absolutely beautiful. And Arnold Friedman once told me that if you really want to know how thoughtful your architect was, or an architect was, is go look at the bathrooms. What do they look like? And I can promise you the bathrooms in each one of these private offices are like the Taj Mahal of bathrooms. They're just absolutely spectacular. So anyway, also then looking at this incredibly beautiful building by Toyo Ito in Sendai, which was very unfortunately damaged quite a lot in the recent earthquake and tsunami there. But that this is a building that really takes advantage of all of these different ideas about structure, about systems integration, and about envelope. So in terms of a diagram, which is that look kind of familiar to the Fort Point channel buildings, but it takes certain elements there. In this case, the structural elements which would otherwise be big, thick wooden columns in a Fort Point building, and begins to make them usable. Distributes them in a way in the plan that they can create different types of spaces. In some cases, they're very far apart, so you can have larger scale spaces. In other places, they're more kind of frequently spaced, where different types of program can happen. The floors have different floor-to-floor heights to them, many of which are designed to be able to be bifurcated, so that one high space could be made into two lower spaces, depending on the program. For instance, going from lab space to dormitory space, something like that could happen. In this case, it's library and media center. But and then also that one of the things that the Fort Point channel buildings don't do particularly well, I think, is responded all to their environmental context. Really, they have a minor urban response, which is front doors on one side and a slightly larger cornice on the side that faces the street. Again, beautiful windows and all of that, but they are kind of the same diagram on all four sides, no matter whether you're facing south, north, east, or west. And so, in the case of this building, what kind of drew me to it was that it really does look at all different sides, all different orientations quite differently. The south side is a double skin wall, which allows you to absorb all this radiant heat in the wintertime and reflect it in the summertime. It also is something which, because of the double skin, allows these southern winds, which happen in the winter time and sunlight, to be kind of put at bay. The western side is, for the most part, opaque, but where it's not, has these vertical louvers, which make all kinds of sense for solar screening and daylighting and glare control in the spaces. And one more thing here. And then the other interesting thing is in terms of systems distribution, where systems can make their way up through the structure. Most of the time these structural elements are empty, but oftentimes they do have structure and then this kind of multi-point system. But there's also a kind of two-way metal framing system which gloms onto these things, and then a raised floor above that, which allows for systems distribution. So at multiple points in the building, all kinds of systems can be coming up through these larger tube elements and then being distributed through the floors. And so there's a kind of integrated idea there, which is if the SALT was about plenum on steroids, this is about column on steroids, I suppose, and very similar to conserved and servant ideas, say, at places like the British Center for Art. And then there's this building here, which in terms of its next uses, I guess it's maybe a little more limited, but I had to show it because it's not far from here, and if you haven't been here, you have to go. For my money, it's the best building I've seen in Massachusetts in the last 10 years. And this is the one of the new housing buildings at Kripalu Yoga Center. And it was done by Peter Rose Architects. And it's really quite spectacular. Beautiful transformable skins here in terms of sun shading, privacy issues, and glare control. Just a beautiful diagram in general. But I have to say what I like about it is that, in the same can sort of be said of the SALT, is that when I look at the section of this, if one of my students at Northeastern comes to me with that section, I'm like, oh yeah, that's a C. That's you haven't thought about anything, and it's very parochial, and you haven't really thought about systems. But the reality is, upon more deep investigation, you can start to see, and this is a typical plan of a room, that the systems are all entirely integrated and embedded in the structure. And so, in the case of the vertical systems, they're embedded in framed walls, and they can be kind of changed and modified if needed. But in terms of heating systems and cooling systems, this building deploys thermal mass radiant systems to radically reduce energy costs, but at the same time to also enjoy the benefits of super low floor-to-floor heights. And so in the case of this, they had a very serious zoning envelope or height restriction that they had to stay within. And but they also had to run a performa, and they had a very constricted site. They had run a performa that if we can't get X number of rooms, and I won't pretend to know how many that was, we're not going to be able to make this work financially. We won't be able to get the revenues back to cover the cost of the financing. And their initial ideas were I want to say they were able to get 5 stories in this, and through beginning to integrate the systems, compressing the floor to floors, they were able to get a whole nother story, and therefore a whole nother kind of bunch of rooms here to help pay for all of this and help with the financing. So it's really an incredibly beautiful building, and one which takes to the sort of a whole nother level the idea of thermal comfort, low energy use, and systems integration. And then one of the other important pieces to this, and this project has a similar diagram in terms of the section. This system actually radiates heat and or cooling from the ceiling downward. So it's a radiant ceiling instead of a radiant floor. And you know, a lot of people say, well, what, you know, heat doesn't rise, so that doesn't make sense for your heating. But when you think about it, radiation doesn't work by gravity, it works by radiation. And so if you can be heating that ceiling, which in turn is heating the floor and the spaces around it, and you're getting thermally active surfaces, you know, you are, and I'll credit Kyle Moe for that particular title, thermally active surfaces. The idea is that you can dramatically lower your energy use and have a better level of comfort, particularly from the ceiling where you can get much broader coverage. Whereas if it's in the floor, you put down a rug, you've shadowed it, if you put down furniture, tables, all that stuff, you begin to really diminish the amount of radiation that you can reap from that. And most importantly in this building, the ability to have an envelope which changes throughout the course of the day. So this is an occupant-activated facade which controls daylight. In the morning, this is, you know, you don't see maybe one or two of these panels up. As the afternoon begins to come on and the sun comes around to the west, which is the west facade, you begin to see all of the colors come out in these shades coming up, and it's a really beautiful way to have these shading devices between the cavities of a double skin wall, which also becomes, as you can see here, a ventilating shaft. The shape of the building and the shape of the blade at the top is all meant to enhance the kind of Venturi effect and the ventilation of the building. A couple student projects, just to show what we're up to there at Northeastern in terms of this idea. I thought this was an incredibly clever idea by a student where they decided to take as a prototype to study for structure this very innovative parking garage in Heilbronn. And the idea was that these are just concrete slabs, block and plank, with a sort of long spans, you know, 54-foot span of steel. And so they began to take that as a primary system and begin to add, not unlike the GSW building you just saw, a double skin wall with all of these same ideas. And you know, so what we're pushing with the students there is for them to be thinking about this idea of free space, clear span, adaptability with integrated systems. And so in the case of this hollow core plank, they were pumping hot air and cold air through this to create radiant surface to heat and cool the building. So all you know, fairly interesting ideas. And you know, we have them go through all the requisite diagrams to, you know, to solve that. Another student project here, real quickly, which used basically stacked wood that was post-tension. So basically stacking wood up, compressing it with the assistance of some metal cables and stays and things like that as a way to create a primary structure for a building that when the building is done, it can all be disassembled and brought back to the lumberyard. Not a single hole goes in any of it. Based on the idea of Peter Zumthor's exhibit at the World Fair a couple of years back. And so really this idea that the students were looking at is where, you know, where does the building, where can it be generic and where does it have to be specific, and what are the ways you address that in terms of where the building touches the site. It has to have certain, it has to fall into a certain logic of the campus plan. In this case, this is on the campus of Tufts University. But once it gets above it, it can be freed up to sort of be more general and then begin to really start to play into this next use and really looking at different ways. These are those kind of beautiful stacked wood structure system that they used, and then just some of the ideas there. And then another way of looking at next use, which is really more about recycling. This is a project we're doing for a company called Save That Stuff. This is a shipping container office building for them. And I guess I probably don't need to talk about the whole shipping container dilemma we have, where every single day in the U.S., many, many thousands of these keep piling up because of our trade deficit. But in this case, you know, for some reason we get a lot of requests for clients who want shipping container buildings, and for the most part, I'm pretty successful in talking them out of it because. In general, depending on the building type, it's actually a relatively bad idea. There's thermal bridging issues, there's all kinds of problems with it. The aesthetic idea of it's great, but if you really want to capture that, if you want to do this right and be sustainable, you really should be insulating the outside of it, in which case you lose the whole dynamic of it. In this case, I I talked to the client about it. They're a recycling company. That's what they do. We figured, all right, for you, it's worth doing. So we tried it. We got through it. We designed it. We got it costed. It was too expensive. So then they decided to go a different route. And I really like this idea, actually. They bought used construction trailers. And we're right in the design process right now on this. And looking at trying to take these construction trailers as modules and build them into, you know, a whole working office building. And so this is the quick take on it, some quick sketches of it. There's you know, our first attempt at this had the kind of flat roofs that these boxes would have because of shipping criteria and all that. The client didn't like that, so we came up with this removable parapet idea, which then gave him a slightly more dynamic look to this, and they liked that a lot. So it became this kind of three-dimensional calling card for their firm. And someone asked me earlier about deconstructible buildings. Well, this one not only deconstructs, but it's on wheels, you know, forever, and it will never come off wheels. And so at any time they can pack it up. And the reason they want to do this is that their lease runs out in 9 years, and if they're going to invest all this money in their offices, they want to be able to take it with them if they have to move. Talked about this house earlier, just some of the strategies of creating framing the stairs so that additional floors could be put on it, clear spans so that, you know, different types of reconfigurations can happen fairly painlessly. You know, so just recapping quickly: structural robustness, systems integration, multi-point plenum, embedded, facade flexibility and daylighting, component transformability. In this case, this is a project we're doing up in the city of Lynn, where an old 18-story first floor of a building was given a mezzanine level a long time ago, and we were able to carve out pieces that are creating double height spaces, but also keeping some of the two-floor components, and then dimensional flexibility. And so I'll just leave you with what I think Western Mass's greatest next-use building is the tobacco barn. I don't condone smoking, but you know, they're not all in the middle of fields. They often happen in these you know, semi-urban arrangements. They have great, you know, graphic capabilities, robust structure, and a facade which is transformable throughout the day. So and you see them nowadays in a kind of modern expression all over the place. So one of my favorites. So anyway, that's all I have for you. So if there's any questions, please let me know. And I'm sorry that went a little long. Lawson was over there, leaving me with the laser pointer. Yes?
What was the name of the project?
E+. Yeah, if you just Google E+, you'll see all of the information on it. But it was the, you know, again, an attempt for the mayor to promote this idea that buildings can start to be less of a drain on the city's infrastructure and grid, and more of a, you know, more of a contributor to it.
So if you ask you the architect just to be able to create a building that could be, or have a reasonable price where you have to get between solar and geothermal, is that?
The way it worked is that he put this out there as, here are 3 real sites, and they are there for the taking. If somebody feels like they can develop these, you know, with a team of not just a design team, but also a developer team, that the developer team is now responsible for the execution of this thing, which is, you know, can they build it for a certain cost, which then allows them to sell it at a profit. And so that's what made it more interesting, is that it wasn't just an ideas competition. It wasn't just, I mean, the ideas competitions are great, but you know, they don't necessarily lead to things they don't always lead to things that are immediately executable. But in this case, you know, I can tell you right now, they really raked over the grills. This developer had him in, talked about his numbers. Are you sure about this? Are you sure about that? Can you really build this? Are you committed to this? And so, you know, there's and I think they're doing it with all the different design teams and developer teams. But that there's, you know, when it's awarded, it's expected that it will be built. we'll see if it works. You know, I'm confident of the technical side. I'm hopeful of the marketing and the sales side. You know, the financial side. Yes.
In the Harvard School, you were talking about the tunnel which you have made.
We didn't make the tunnel. The tunnel was there.
Yeah, yeah.
Yes.
The
and it's actually not there anymore.
Yeah,
but
the floorings.
Yeah.
So, what material have you used? Any special material or a general concrete slab with reinforcement?
You're talking about the data center project, with the particle physics labs and all that. In the case of that, the existing conditions there was above the tunnel, a 3-foot concrete slab, solid, with 1 inch of lead, and then 3 more feet of concrete. So that's 6 foot 1 inch of the heaviest stuff you can imagine. In terms of the new infill floors, we wanted those infill floors not to take away from the original shell of the building, which was clear span, front to back, super high. And so all of the infill was done generally with light materials. So rather than infilling with heavy concrete floors and thermal mass, which I would always love to do, we took an approach that this space could continue to be a great next-use space by infilling it with kind of objects that became labs and things like that, but were able to be pulled out of there at some point if they needed to be, if they needed the whole high bay space back again. So it was everything was raised floor systems, so to really have as much infrastructural flexibility as possible, but otherwise it was steel, metal decks, things like that.
So, like working in a green building firm and working for environmental friendly products and constructing green buildings, do you still favor the concrete usage in the buildings, or your company has some different materials, construction materials, which you use to prove that okay, fine, this is a green building and we have used these environmental friendly materials?
Well, I suppose it depends on the scale of the building. Of course, I mean, obviously when we work at the small scale of the wood frame, hard to mix wood and concrete. And where we can, we try to come up with framing systems that reduce the amount of wood, by quite a lot in some cases. But I still contend that where possible, if you can use concrete on the inside of the building for your lateral support, as well as for your floors. And you can convince the client of all of the niceties of integrated systems like radiant heating and all that, that those are really the best systems for long-term durability, low energy use, and there still is the problem of embedded energy in concrete use, but at the moment, no. I mean, we haven't come up with a sort of better system than that, and really thermal mass being the kind of the key player whenever possible, if you can be using that. So, all right. Yes.
I'm wondering if your firm or you and your partners began taking interest in adaptive reuse when you started focusing more on the Boston area, or if you were interested in that and focusing on that approach prior to that. Because I think of adaptive reuse as being something that's very useful for an area like Boston, and actually for everywhere, but it seems to be more.
It's particularly useful in Boston, yeah. And I would say, yeah, my partner Mimi was kind of probably always more interested in that than other things. When previously I had only done 2 adaptive reuse projects. One at the Provincetown Art Museum, one at the Stone Barns project, and then when we started looking for work in Boston, realizing there's not a whole lot of sites. There's a lot of old crappy buildings that need to be renovated, right? That we quickly sort of became self-conscious about the fact that we needed to be able to do more of that. So, but I just like the story of it. I mean, there's so much beautiful building stock in Boston. Land is so expensive. To be able to reuse these buildings, great. And it's a good green story. It's a good historic story. It's a good urban context story.
And it seems like part of your story of what you're advocating is designing so that the building can be reused later. And so I was thinking about new construction in terms of its longevity. And I guess I wonder at places where it's not as necessary to reuse the existing footprint.
Where would that be?
Places like Colorado, like places.
Well,
where-
but I don't understand why it wouldn't be useful to have a building that has longevity there.
Oh, no, I'm not saying it isn't. I just think that there's not as much of an incentive, and I wonder if there, if you, I mean, I'm a huge advocate of adaptive reuse, and I guess what I'm asking is if you see a way to incentivize this for places that don't feel as much of a pinch in terms of their property.
Yeah, no, I think that's an excellent point. It's the incentive side of this. I do think, like the geothermal in that house that we did was fairly heavily subsidized by tax credits. The PV panels we're using on a lot of these projects, at the end of the day, they're almost free because of the way they're incentivized. But things like, well, here, for instance, in Switzerland, they have a 100-year mortgage program, right? Where if you build your building to certain specifications out of certain materials, instead of a 30-year mortgage, you can get a 100-year mortgage. I think things like that, if those types of programs could be, at a policy level implemented, I think that would be incredibly helpful. I also think tax credits based on more robust buildings in general would be an excellent way to incentivize these things in those kinds of areas where you can throw a Butler building up for $40 a square foot, and then you tear it down in a couple of years, and who cares because it didn't cost you much. But so yeah, I mean, I think at a policy level, I mean, there's still an awful lot to be done in terms of making this more attractive in places like that. So, but I don't have any good specific answers for that. I mean, it's kind of the generic. I think the Swiss example is a good one.
It's one of those things that until it becomes a problem, I think people don't care, and it would be great if there was a way to keep it moving ahead instead of just expanding where they can and then.
It's one of those problems of it, right? It actually requires foresight, which most policy doesn't revolve around, and it doesn't have an immediate impact. It has a 40, 60, 80, 100-year impact, right? So in that sense, finding the political will for it, I'm going to guess is tricky. Anyone else? All right. Thank you.
Thank you.